All right, now let's talk that ever popular of physics topics, forces. We do have a little bit of motion involved in this section as well, but we are going to be looking at force diagrams and all the calculations therein. So, here is an example. Let's say on the floor there sits a box, a 15-kilogram box, pretty substantial. Said box is on a fairly slick surface. That fairly slick surface has a coefficient of friction of 0.204. Coefficient of friction is, again, how bumpy is the floor. Said box is being pulled along the floor by a force of 35 newtons at an angle of 30 degrees to the horizontal. So let's say somebody has a rope or a strap over their shoulder and they're pulling. Let's say that they are pulling the box along the floor, so it is moving along the floor at a constant speed. So, let's say that, oh no, let's not say that. Let's say that it is moving along the floor. I actually don't know if it's a constant speed yet, but since this person is pulling it along the floor, I know there is no up-down-ness. My box is moving horizontally along the floor. Well, we want to find all of these things: force gravity, force normal, force friction, and the possible acceleration of this box. I know it's moving along the floor, but I actually don't know if it's moving at a constant speed or not. So let's get a crackin'. So, whenever you're looking at these types of problems, always start with gravity. That is the most straightforward, easiest place to start. Gravity acts straight down from the object. I don't care if your object is tilted or not. Doesn't matter. Always happens straight down. Force gravity is calculated by multiplying the mass, 15 kilograms, times our acceleration due to gravity, 9.81. So in this case, 15 kilograms times 9.81 meters per second squared is going to give us a force gravity of 147.15 newtons. Forces are measured in newtons. No, not the cookie. So, acting opposite of our force gravity is something called the force normal. The force normal is the force exerted by the floor against the object. So this is the force that keeps you from being yanked through your chair down towards the center of the earth. This is the force that keeps the book on the table from going through the table. This is the force up from the object, or up from the platform, whatever it's sitting on. If you tilt the platform, remember, the normal force comes out of the surface. So if you tilt the force, or if you tilt the platform, God bless him, you tilt the force as well. So, I know that my object is not moving up or down. If you remember your Newton's laws, if it is not moving up or down, that means that the net force in my y direction must be 0. However, if I look in the y direction, I have force gravity pulling down, I have force normal pushing up, but that's not all. My force applied also has a y component. This is a triangle. So I need to find my force applied in the y direction before I can start talking about that normal force. Force applied on the y-axis here, I can use my sine function to find that. So sine of theta is going to be opposite over hypotenuse. In this case, opposite is my FAPI. And my hypotenuse is my applied force. So if I rearrange that, I'm going to multiply both sides by FAP. So that's 35 sine of 30 gives me a value of 17.5. All right, now the only force that I don't know in the y direction is my force normal. So now I can actually make some progress. So my net force is the sum of all forces in one direction. Can you see that edge there? There you go. So that means my normal force and my FAPI that are pushing up, as well as my gravity that is pulling down. I know my net has to be 0. I know FAPI is 17.5. And I know gravity is 147.15. That means normal is all I don't know. Algebraic fun, solve for Fn. And we end up with 129.5. for that normal force. Again, we had no up and down motion. It is moving to the side. I know this. So that's what tells me that my net force in the y direction must be 0. Now, my net force in my x direction will not be 0. A change in motion, well, actually, it might be 0. I don't know. Because in order for there to be an acceleration, I must have an unbalanced force. Newton's second law tells me, actually first law as well, an object will continue doing what it's doing unless acted on by an unbalanced force. So in the x direction, I have the applied force, the x component of my applied force, but remember this is on a bumpy floor. This is not a slick floor. So I also have a friction force that is opposing that forward motion. Otherwise it would just fly to its heart's content. This little beauty right here is what's going to help me find that friction force. Mu, coefficient of friction, is actually a ratio between the friction force and the normal force. Since I know the normal force and the coefficient of friction, I can find my friction force. So force normal times my mu is going to give me my friction force. So that's 0.204 times 129.65 gives me just under 26 and a half. So now let's talk about that horizontal direction. Let's talk about the net force in the x direction. What do I have? Well, I've got FAPX going in the positive direction. I've got friction pointing in the negative direction. Y'all should scold me. I did not tell you which was positive and which was negative. Bad habit. Badness W. FAPX. Ooh, I need that. Let's see. Cosine would give me that because it's the adjacent side. So let's see. Cosine of theta is my FAPX over my applied, my FAP. So 35 times my cosine of my 30 is going to give me my FAPX. So 35 cosine of 30 is going to be 30.31 in the positive direction. My friction force I just found, 26.4486. And that gives me a net force in my x direction of not 0. Because my net force in my x direction, because my force in my x direction is not 0, that means that there is in fact an acceleration in my x direction. Let's figure out what it is. F equals ma will give me that acceleration. The force I just found. My mass, it's 15. Solve for acceleration. So 3.86 divided by 15 gives me 0.257 meters per second in the forwards direction. So I am out of time. I have a second problem for you. You can see at the bottom, and you will find that in the next video. I hope to see you there.